Seems to be broken. Now, the set of things to consider in how likely it is to be broken is actually quite broad. You can look at structural complexity of the code, cyclomatic complexity, depth of decision nesting, those kind of things. You can look at how recently the code has been changed, how reliable it's been in service.
I like
Go
just
ahead.
the developer scare factor. How scared are the developers of that area of code is often a good sign just by itself. It's like, I don't want to go in there. Or how many people know that area code is another great sign for that kind of stuff. That
Sure,
that says,
sure.
wow,
Yeah.
yeah, that one's that has higher risk than parts of the code that everyone knows and everyone understands and knows how to work with.
hmm Yeah, and on the other hand, if you're friends with the testers, if you still have a legitimate test organization, if you're friends with the testers, you can actually get into an interesting conversation with them and ask them to what degree, simply by knowing the name of the developer alone, can you tell me how likely that code is to be broken?
Oh, that
And their answer,
guy.
yes, yeah, yeah. If Mary wrote the code, not a problem. We're unlikely to find something. But if that person wrote the code, yeah, it's almost guaranteed to
Well,
be
it's the
broken.
old test about if I get hit by a bus tomorrow, right? You know, it's like there's certain people in an organization who are maybe algorithmic gurus or the core functionality of something that's in a system that is so complex that if they reassign engineers to the program and those senior architects move on to a different project, there's always this issue of like, oh, don't you dare touch that block of code. You know what's going to happen in there.
Right.
Everything's going to go haywire. So that's another risk issue, right? Certainly risk associated with that. Mm-hmm.
Now, we could actually spend an hour just on how do we assess how likely the code is to be broken. However, in practice, today, most organizations are not going to be in a position to reliably come up with a severity with a probability assessment. And so basically what we do here is just ignore the probability. We treat all code as being equally likely to be broken. Doesn't matter how complex it is, doesn't matter. Since we're not reliable yet because we don't have the history, we're just going to call all code across the entire code base equally likely to be broken, and we'll just go from there. Which basically
I want to jump in
puts
here,
us,
Steve, for just a moment,
sure,
because I think this is an incredibly important point in a way.